In the 6th lesson on finance, we're going to discuss the idea of an annuity. Now, an annuity is just the kind of thing that happens when you deposit money every month into your pension account. You're making equal payments at a regular interval. It's also the sort of thing that happens when you repay a loan. Now, before we actually get into the idea of an annuity, I just want you to have a look at this little bit of algebra. Look at the pattern. If I take x squared minus 1 divided by x minus 1, factorize, cancel, my answer becomes x plus 1. If you take x cubed minus 1 divided by x minus 1, okay, again, factorize, cancel, and your answer becomes x squared plus x plus 1. If you take x to the power of 4 minus 1 over x minus 1, factorize, cancel, multiply out those brackets, you get x cubed plus x squared plus x plus 1. I hope you can see the pattern. Can you see that if you're adding descending powers of x, this power here is just one more than that power over there. So x cubed plus x squared plus x plus 1 is exactly the same as x to the power of 4 minus 1 over x minus 1. And this works in general terms. So whatever the power is there, in this case the highest power of x is x to the power of n minus 1, and I'm adding all the descending powers of x, x squared plus x plus 1. That sum is just going to equal x to the power of n minus 1 all over x minus 1. We just need to know that simplification in order to do this sum over here. Now, I've chosen very small numbers here just so that you can get the idea of what is going to happen. All right, we are investing money every single year for a period of 3 years. So we start off here at T0. At the end of the first year, we are going to invest X rand. At the end of the second year, we're going to invest X rand. And at the end of the third year, we are going to invest X rand, and we want to know how much money we have in our account as we make that last deposit. Our interest rate is I% per annum. I've given you the effective interest rate. So in this particular case, it doesn't complicate the issue. All right, so when you're working out the future value, remember that first investment earns interest for 2 years. 1 plus I to the power of 3 minus 1, which is 2. Your second investment earns interest for a period of 1 year, and your last investment doesn't have a chance to earn any interest at all, okay, because the formula we're going to develop tells us how much money we have as we make that last deposit. Here I have a common factor of x. I'm going to take it out. I land up with 1 plus I to the power of 2 plus 1 plus I to the power of 1 plus 1. Okay, can you see essentially I've got stuff squared plus stuff plus 1. Using that result over there, I can say that this is x times the bracket to the power of 3 minus 1 all over the bracket minus 1. When I simplify that further, I'm just going to write it on the side here. We get x multiplied by 1 plus I to the power of 3 minus 1 all over 1 minus 1 disappears, all over I. Now, I just did 3 separate deposits. I mean, if you deposited monthly every year for 30 years, it would be exceptionally tedious to write the sum out that way. So, this we're going to refer to as our future value annuity formula. The only thing I did here is I specified that we only had 3 deposits. So all we're going to do is change that 3 into an N when we write down our general formula. Okay, the future value, this is always how much money you have as you make your last deposit. This is the monthly investment that you're making. I is your interest rate and N is your number of payments. Now, one of the most important things to remember about annuities, please, is that your payment period, okay, in this case, you're investing 800 Rand every month. Your payment period has got to match your compounding period. If those two are not the same, you would have to use that formula for the conversion between an effective and a nominal interest rate. Now, in this particular case, if we have a look at what's happening on our timeline. Okay, you invest 800 Rand every month. Now, unless stated otherwise, we are assuming that you make that deposit at the end of the first month, at the end of the second month, at the end of every month for a period of 6 years. All right, so how many deposits are we making in total? 6 times 12, okay? So we are going to make deposits every single month up to the end of the 6th year. So it would be exceptionally tedious to write out 72 deposits. So what we're going to do is we are going to say the total amount of money that we have at the end of this time is equal to our monthly deposit 1 plus my interest rate. Okay, now the annual interest rate is 12.5% per annum. I should have filled in there that it's per annum, compounded monthly. So in your memory A, you're going to put 0.125 divided by 12. That is my interest rate. I'm doing this over a period of 6 years and I'm making monthly deposits. Subtract 1 all over my A value. So instead of having to write out 72 little sums, we can just put it into this formula. And so we are going to get 800 multiplied by, okay, beg your pardon, I should have put the button 0.125 divided by 12 equals shift store A. All right, so I put my interest in memory A now. Okay, when I type this in, 800 multiplied by, open brackets, 1 plus alpha A, close bracket, raised to the power of 6 times 12. Move the cursor, subtract 1, all divided by alpha A. And I know that in total I will have 85156 Rand and 10 cents. Always round off to 2 decimal places when you're talking about money. Right, the third example I want to do with you. You're investing 250 Rand at the end of each month for a period now of 15 years. Notice again, I have made sure that you're making monthly payments and your interest rate is compounded monthly. So how much is this annuity worth at the end of 15 years? Well, your future value is 250 multiplied by 1 plus your interest rate to the power of 15. We are making monthly payments, 15 times 12, subtract 1, all over our interest rate. And our interest rate I'm going to put in memory A. All right, what is my interest? It is 0.14 divided by 12. That is what I'm storing in memory A. Okay. 0.14 divided by 12 equals shift store A. Calculate how much money you have as you make that last deposit of 250 Rand. We are going to say it is 250 multiplied by, open bracket 1 plus alpha A, close bracket, raised to the power of 15 times 12, move your cursor, subtract 1, all divided by alpha A equals, and you have 151,446 Rand and 57 cents. Okay, so the next question is, okay, you get that amount of money out. How much interest did you earn over the period of 15 years? Okay, well, ask yourself, how much money did we actually put into this account? How much money did you actually put into the bank? Well, you deposited 250 Rand every month for a period of 15 years. That is how much money you deposited. How much money is your future value? How much money did you actually have? 151,446.57. So how much interest did you earn over this period of time? It's simply going to be your future value minus the total of your deposits. So we're going to take that 151,446 and we are going to subtract 250 multiplied by 12 multiplied by 15. So over a period of 15 years, you have earned 106,446.57 Rands worth of interest. Quite a substantial amount of money, and that's the power of compound interest.